Alright, this video is on harder questions involving surds. So we've now come towards the end of the topic where you have learnt how to add, subtract, multiply, divide, surds, you've learnt about special expansions, and you've learnt to rationalise the denominator. But now we're looking at questions which require you to apply different parts of the topic, and it may be unfamiliar. Let's have a look at two examples in this video. This is the first question. It says if this expression, so it's root 3 plus root 2 over root 3 minus root 2 minus root 3 minus root 2 over root 3 plus root 2 equals root p, find p. So we've got this complex expression here, definitely more complicated than we're used to, and then we're told that it equals this nice little expression root p, and we have to find p. So even once we finish the question, we know, even once we, tidy that expression, that circled expression, we know there's just even a further step to go. So what we've got to think about is how to approach this question. Well, clearly I'm going to have to do something with that expression. So what I can do to set this out nice and clearly and to show whoever's reading my work what I'm doing, this expression is called the left-hand side of this big equation. And so what I'm going to do is I'm going to write left-hand side. And I'm going to start by working with the left-hand side. Clearly that's the side that I can manipulate or simplify the easiest, okay? Or the most easily. All right, so let's write that expression down. There is my left-hand side. Minus root 3 minus root 2. Now, what can we do with this? Well, there's two different fractions, so we could form a common denominator. The other thing we could do is we could rationalize each expression. Okay, it actually doesn't matter. I think they both work out to be about the same amount of work. So let's have a look at what happens when we form a common denominator. Actually, no, I'm going to change my mind. Let's actually rationalize them because that's what we've just done work on. So let's take this first fraction. We've got root 3 plus root 2 on root 3 minus root 2. Now, if I'm to rationalize that, I want you to think about how we're going to make that denominator rational. Well, when it consists of two terms, excuse me, when it consists of two terms, what we need to do is come up with the other half of the difference of two squares. So if we have root 3 minus root 2, I'm going to put the other bracket that will make a difference of two squares, and that's root 3 plus root 2. And I need a difference of two squares because when you multiply a difference of two squares containing surds, you always end up with an integer, and that is always rational. So whatever I put on the denominator, or whatever I multiply on the denominator, I'm going to also multiply in the numerator. We're going to do that to both the fractions. So I'm going to write my second fraction down, this expression over here, and then we're going to rationalize that as well. Alright, so to rationalize, once again, we need the other half of your difference of two squares. So that would be root 3 minus root 2, because the difference of two squares you must have, the brackets must contain different signs that join the terms. So here I've got a minus and a plus and a plus and a minus. Alright, so a reminder to you that when I expand a difference of two squares, so if I have a minus b, a plus b, the fastest way to, look at my writing, excuse me, the fastest way to expand that would be to square the first term minus the square of the last term. So let's apply that knowledge. So if I square the first term, I'm going to get 3 minus the square of the second term will give me 2. And it is always a minus in there. In the numerator, I can see I've got the same expression multiplied by itself. So what I'm going to do is write that as root 3 plus root 2 all squared. If I look at the second term, once again, this difference of two squares here, well, that's going to give me 3 minus 2. So the denominator, you can already see 3 minus 2 is 1. That's going to turn out really nicely. And then in the numerator, I've got, once again, an expression multiplied by itself. So I'm going to write that as root 3 minus root 2 all squared. So we'll need a bit more room. So let's keep going. What we've finished with, actually, let's go back to that previous line. What I can do before I write the next line is I can see both of those will simplify to 1. So really, anything over 1 will just be the numerator. So what I have is root 3 plus root 2 all squared minus root 3 minus root 2 all squared. Let's write that down. Root 3 plus root 2 all squared minus root 3 minus root 2 all squared. Just quickly check that. If you write the wrong thing, you're in trouble. All right, so now we're going to be talking about how to expand a perfect square. So it's definitely checking that we understand or know how to do lots of different processes. For a perfect square, it's going to be square the first term, multiply the two terms inside the bracket and double them, and square the last term. So let's do that. Square the first term, multiply these two surds together, that's root 6, and double it gives me 2 root 6. Plus, square of the last term is 2. Let's repeat that again, but with this bracket. So, square the first term, multiply these two surds together, that's minus root 6 because of this minus here, and double gives me minus 2 root 6. Square this last term, doesn't matter that it's negative because when you square any number it becomes positive, and we get a 2 when I square this root 2. Now I just have to make sure I carry this minus through the bracket, or you can also think of that as multiplying by minus 1, whichever way is easier for you. So we're going to get 3 plus 2 root 6 plus 2 minus 3, because minus 1 times 3 is minus 3, plus 2 root 6, because that negative there and that negative when we multiply become a positive, and a minus, and this positive over here will make a negative, and 1 times 2 is 2. Now it's just a matter of collecting all my like terms that can be collected together. Now, what's happening there? I'm hoping you notice that the 3 minus 3 will cancel, the 2 minus 2 will cancel, so all I'm left with is 2 root 6 plus 2 root 6. Well, hopefully you know that that is 4 root 6. Now, I was told that this expression would equal root p. Well, before it was 4 root 6, it would have been root 6 times the square root of some number, and the number I can square root to get 4 is 16. And if 4 is joined to the root 6 by times, well, there must be a multiplication there. So root 6 times root 16, well, that's root 96. So what does that mean p equals? Hopefully you can see that if p is the number under the root sign, then my p must be 96. So I can say p equals 96. That's definitely a trickier kind of question. So you may need to watch this video more than once to get your head around it, but these are the kinds of questions we want to aim to be able to do in the long term. You don't have to be able to do them all straight away, but being exposed to them is part of it, and also attempting them on your own is another part of it too. So you may wish to repeat this solution by yourself, and then if you get stuck, you can always fast forward to the part of the video where you're stuck and try and figure out where you've gone wrong, and then start again. So don't give up. All right, good luck.